And welcome to my presentation. I'm Kezangla. The topic of my presentation is the Silk House Project, a smart microgrid. The Silk House, or the Casa Seda, is located in northeastern part of Portugal under the municipality of Bragança near Bragança River. The house was used for drying silk during 18th and 19th century and as a mill during 20th century. But now it is converted to a museum known as Bragança 7th River Science Center. It was connected to a main grid of 400 volt 50 Hz, contact power of 13.8 kilowatt hour. Average energy consumption was 45 kilowatt hour daily and 16,000 kilowatt hour annually. The Silk House project, a smart microgrid, was conceptualized in 2017 as a development of smart microgrid based on renewable energy source and a monitoring system for the House of Silk. It was motivated by global challenges like climate change, economic and health crisis, for penetration of DER and DG sources, for mitigation of the disaster and improved reliability of the system. It was promoted mainly by Polytechnic Institute of Bragança with other partners, and it is funded by European Union. The objective of the Silk House project was to transform Silk House into a self-sustainable energy building and enhance the dissemination of science in the Silk House. Key components of the Silk House project are PV microinverters, PV inverters, solar photovoltaic, energy management system like Sunny Home Manager, pico hydro turbines, horizontal water wheels, and energy storage system. Along the process of Silk House project, there were many milestones to be achieved. Milestone number 1 was design of a smart microgrid for Casa Sada based on renewable energy source. 2 was development of prototype for pico hydro system to be implemented in the old mill of the Casa Sada. And also implementation of monitoring system for riverside area. Before design of any microgrid system, there is a specific requirements. Number 1 is the microgrid to be self-sustainable for net zero energy building, and it should have an electric grid as an external energy source, but energy injected into the grid must be zero. It should also have an energy storage system in order to improve the self-consumption and self-sufficiency quotas. The generated energy should be from renewable sources like photovoltaic and pico hydro with the use of innovative solutions. It should also have power management and monitoring system. Based on all these requirements, the Silk House microgrid was designed based on SMA flexible storage system with better backup and increased self-consumption. Looking at the general circuitry overview of the smart microgrid, you can see that photovoltaic generation, pico hydro system, battery energy storage system are all connected to the microgrid using bidirectional inverters, and also have a 3-phase automatic transfer switch for disconnection from the utility grid. It has also a central device known as Sunny Home Manager. There were 2 available on-site renewable sources, namely hydroelectric and photovoltaic. Hydroelectric was convenient because there was a river Bragança which is flowing nearby the Silk House, and it also has a small dam. The Silk House has a mill which contains hydraulic infrastructure. It has also canals and galleries. Therefore, upper gallery was used to install microgrid equipment, and lower grade gallery was used for installation of 300 watt horizontal water wheel and 1.2 kilowatt low head turbine. Regarding the photovoltaic system installation, silk house has a roof with a slope of 12 degrees and two shadowless areas. One PV string was oriented south and two others PV string was oriented southwest to improve the distribution of PV generation throughout the day. Regarding the PV integration to the microgrid, it was integrated through two systems, horizontal water wheel and low head propeller turbine, which in total generated about 1.4 kilowatt of power. It was generated to the microgrid, integrated to the microgrid using PV inverters through overvoltage protection. Regarding the photovoltaic integration to the microgrid, the photovoltaic system was able to generate about 8,775 kilowatt hour of the energy, and it is connected to the microgrid using SMA Sunny Boy PV inverters. Now, with the objective to get net zero or energy sustainable building, there should be a balance between the generation and consumption of the energy. By looking at all the table and the graph, the hydropower is able to generate about 7,200, and average annual demand of the silk house was about 16,000. Now with the expected energy saving of 1,900 kilowatt, PV system has to generate about only 7,171. The total yield of the PV generation was found about 4,748 kilowatt from September 2019 to August 2020. And looking at the consumption and generation energy balance from July 31st, 2019 to September 9, 2020, it is able to achieve the target. Now to microgrid to run in a stand-alone or self-sustainable energy storage system is very important. Therefore, energy storage system of 48 volt battery bank, which consists of 24 VRLA 2 volt battery blocks, was installed in the Silk House project. Now regarding the energy management, it was based on the SMA flexible storage system with the battery backup and increase of self-consumption. Sunny Home Manager 2.0 was the centralized energy manager, which is a Sunny portal and which has a monitoring and power control and energy management capability. Now Silk House project, the smart microgrid was successfully implemented and operational now. It was in 2017 through conceptual design. It is now fully operational. Regarding the challenges, development of pico-hydro system prototype for the old mill was found challenging, and there is also a plan to integrate Silk House into a permanent exhibition and provide platform for the students and senior technicians for training, learning and new scientific activities. Now to conclude my presentation, the Silk House is transformed into a self-sustainable energy building, and it is now a demonstration site and a dynamic platform for innovative energy solutions reproducible in the future smart cities. It has a smart microgrid using renewable sources and energy monitoring system which can operate in both grid-connected and islanded mode. It is based on the SMA flexible storage system with a better backup function and increased self-consumption. The power control and energy management are carried out by SMA Sunny Island battery inverters and a Sunny Home Manager. The power generation is achieved from two renewable sources available on site, namely photovoltaic and hydro system. Thank you and touch the leg.